Interference of sound waves. Sound waves interfere in the same way that waves do in space. If we look at this illustration, there are two speakers. We'll say speaker A and speaker B. Speaker A being the top and speaker B being the bottom. Both of these speakers, when they emit similar sound waves or wavelengths of similar frequencies or wavelengths, the waves will propagate out, travel out in spherical shells. If we take note of the light blue waves, the area of the waveform increases with distance. So this is the crest, 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 crest as we go out, and halfway between crests would be troughs, troughs, trough, trough. Speaker B on the bottom will have purple waveforms, crest, 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 and these repeat. It's an example of simple harmonic motion. And it's interesting to note, wherever a crest from speaker A meets a crest from speaker B, the waves are said to be in phase. So if we look at the next slide, we've created red dots where the crest for each of the sound waves coming from the speakers meet up. So at this location, the crest from waveforms from speakers A and B line up, line up, line up. These are regions where constructive interference occurs. So if you were walking in space and you were standing at the location of any of those red dots, you'd hear a relatively loud sound. The opposite of constructive interference is destructive interference. The next slide shows where the crest of one waveform, let's look at this location the location right here. The crest from the purple wave matches up with the trough of the light blue wave. And at that location, when a crest meets a trough, the waves are said to be out of phase. So any of the green dots within the presentation are associated with points where destructive interference is occurring. And destructive interference will actually not be associated with loud. It would be the opposite of that, soft. Now we take the two previous slides and create a composite image. So we take the slide for constructive interference, red dots, and superimpose it over the slide for destructive interference, green dots. And it's quite interesting. There are patterns that are quite magical that are apparent. Within space, we get fingers of or lines of constructive, destructive, constructive, destructive, and constructive. The illustration on the left-hand side is associated with sound waves. Interference not only occurs with sound waves, it occurs with, it's a property of waves that can be applied to any type of waves. This is a picture of water waves in a ripple tank on the right-hand side. Instead of having two speakers, we have two, let's just say, bugs located at one location, top and bottom, similar to the speakers. And these bugs bob up and down, creating two separate wave sources. When these waves travel out in space, just as the sound waves, at some locations we'll experience destructive interference. So if you look at this wave tank, there are no waves at those locations. These are called nodes, and they're pointed out with the green arrows. 3 of the 4 visible nodes are pointed out. And the opposite of a node is an antinode. These are locations where we have red dots, or we have wave motion occurring. So this is a location where waves are at a maximum. Again, a maximum and a maximum. If we were to create, well, let's create a line. And we'll make this line yellow. And I'll draw that line from the top to the bottom. If we were to walk along that line, let's walk the line. If we're standing at that location, we hear loud. If we stand here, soft. At that location, loud. Right here, soft. Loud, soft, loud, soft, loud. This is called a fringe pattern. Again, sound waves exhibit interference. Constructive interference occurs when two crests meet, and destructive interference occurs when a crest and a trough meet. This means that when a listener is located where constructive interference is occurring, there will be a loud spot, and that when a listener is located where destructive interference is occurring, there will be little or no sound.